Okay, so welcome to the second video on slopes. So there's actually a slope formula. So let's start there. So the formula for a slope is given as follows. For a line through points x1, y1 and x2, y2, m is the symbol for the slope. Slope is equal to y2 minus y1 divided by x2 minus x1, also known as the rise over the run. And honestly, it doesn't matter which way you do this subtraction as long as you're consistent. So the important thing to note here is that this coordinate is right here and this coordinate is right there, right? Do you see them? They come in pairs. Don't mix that order up. So let's see if this formula actually works, right? So here we have a picture. We know when we look at that picture, the slope has to be positive, right? So by observation, we know the slope has to be positive. And we can figure this out by counting blocks, right? Because we can say that one there, this one here, and how do we go? Let's see. From here, we would run there. What is that? 1, 2, 3, 4, 5, 6. And then we would go up 2. So the slope, m, the symbol for it, is equal to the rise over the run. And in this case, it would be 2 over 6 or 1 over 3. Now, that's the old way of doing it. Can we use our formula to do this? Well, we can. This point here, the coordinate for this point right there is -3 and 2. The coordinate for this point right there is +3 and let's see, 1, 2, 3, 4. Right? So we have 2 points, -3 and 2 and 3 and 4. And so we think of this as x1 and this is y1. We can think of this as x2 and this is y2. So according to the formula, our slope would be y2 minus y1 over x2 minus x1. So in this case, that would be 4 minus 2, 4 minus 2, and 3 minus -3. Okay, careful with this. It's always subtraction between them, and then the signs work themselves out. So in this case, it will be 2 in the numerator, and 3 minus a -3 is 3 plus 3, which is 2 over 6 or 1 over 3. So you can see that you get the same slope whether you counted blocks or whether you use the formula. Let's use just to convince yourself that it doesn't matter which points you use. Let's pick another point, right? So let's use this point here because it's nicely on a square. Let's find another one that's nicely on a grid there. That one there, what do you think? So that location right there is, what is that spot? 9 for the x, eyes getting old here. That's 6 for the y, I think. Put my glasses on. Yeah, much better. Alright, so let's use 3, 4 and 9, 6 to find the slope. So again, this time we'll let this one be x1 and this one be y1 and this be x2 and this be y2. So now our m slope is equal to y2 minus y1, x2 minus x1 equals to, so that would be 6 minus 4 divided by 9 minus 3, which is 2 over 6 or 1 over 3. So it doesn't matter which points you use, as long as you're using 2 points and as long as you're doing the formula correctly, you're going to get the same slope. Right? And that should make sense. I mean, after all, if it's a straight line, the slope doesn't jump up and down, or shouldn't change. Right? It should be the same. So here we go on this one. So when I look at this by observation, right? By observation, we know the slope of this slope should work out to be negative. Should be negative. Let's see if we can actually figure the slope out using the formula. So I'm looking for some points where it nicely crosses. So that one there seems like it crosses nicely. And I'm going to use this one here, right there. So this point right here is 0 for the x, minus 1 for the y. And that one right there seems to be minus 2 for the x and 5 for the y, right? And again, it doesn't matter which pair you think of as x1 and which one you think of x1, y1 and which one you think of x2, y2. Just be, once you name them, stick to the formula correctly. So I'm going to think of this first one this way, and x2, y2, and so m is y2 minus y1, x2 minus x1, so y2 minus y1, x2 minus x1. So up here I have a negative 6, and down in the denominator I have a positive 2. So negative 6 over positive 2 is negative 3. Now, just to prove to you that it doesn't matter whether I chose these different naming for the coordinate. For example, what if I had called this one here x1, y1, and then this coordinate there x2, y2? Would I get the same answer? So m this time is going to be y2 minus y1, x2 minus x1. So in this case, it's going to be 5 minus minus 1. And in the denominator, I have minus 2 minus 0. That's going to be 6 over minus 2, which is negative 3. So you can see that no matter which way you do the which way you name the coordinates, it doesn't matter, you're going to get the same slope value. And notice how the negative, which we expected, also worked out nicely in this problem. Alright, so I hope that helps with the slope formula. Let's see, I don't know, let me just do one more. I'm just, abundance of caution here. Let's say that we have the following: find the slope. Find the slope between 3, 5 and minus 1 and 5. Okay, so no picture this time, just given you 2 coordinates. It doesn't matter. We just got to figure out which one we want to call x1 and y1 and which one we want to call x2 and y2. So I'm going to name it this way, and you could have named it the other way, right? It doesn't matter. So slope m is equal to y2 minus y1 or x2 minus x1, which is equal to y2 is 5 minus 5 divided by minus 1 minus 3, 0 over minus 4, which is 0, slope of 0. Now don't say this has no slope. The slope value is 0. What sort of line is that? What sort of situation is that? Well, let's take a look, right? Let's take a look. So let me draw a grid. So here is 3, and here is 5, 4, 5, so 3, 5. And here is -1 and 5. Right? And you can see that if I connect these two like so, that's a horizontal line. Right? In fact, we know the equation of this line. This is the equation. This is the line y equals 5. Horizontal lines have a slope of 0. Right? So horizontal lines have slope 0. Now please, please, please never say no slope. Never say no slope, right? Because what does that mean? That means that does it mean the slope is undefined, or does it mean the slope is 0? No slope is ambiguous. If it's a horizontal line, the slope is 0. Just say slope 0. Never say no slope. Let's take a look at the slope of this line. Find the slope between 5 minus 1 and 5, 3. So again, we get to pick which one is x2 and which one is x1. I'm going to just change things up and call it this way. And so m is equal to y2 minus y1 divided by x2 minus x1. So this is minus 4 over 0. And when you divide by 0, which cannot be done, we know that this is undefined. Undefined, right? So what kind of situation would give us a slope that's undefined? Well, let's take a look at a picture. So this one, the first dot is 5, negative 1. 1, 2, 3, 4, 5. So 5, negative 1. So that's like there. 5, negative 1. And the second point is 5, 3. 1, 2, 3. It's like there. So this is a vertical line. This is the line y equals 5. A vertical line. A vertical line, vertical lines have undefined slope. Right? Have undefined slope. So if the slope is undefined, you know it's a vertical line. And this is the reason why it's not good to say no slope, because what does that mean? Does it mean it's undefined, or does it mean it's 0? So if it's a vertical line, always say undefined. Cannot be defined. If it's a horizontal line, always say the slope is 0. And you can figure that out using the slope formula or by inspection. Okay? All right.